Welcome back. This week, Jackson Chastain explains land spouts and how they form. Here's Weatherwise.
Meteorologist Jackson Chastain here with the latest edition of Weatherwise. Today we talked land spouts. Last week we talked water spouts. Land spouts are actually a very similar, if not identical phenomenon. The only difference is that they form over land. And I'm just going to go over that formation process and then kind of compare that with the supercellular tornado, which you might be more accustomed to. And in fact, I don't think a lot of people know the difference between a land spout and a supercellular tornado, since they are both counted as tornadoes. But one of those main differences is that you have to have a boundary. So like the water spout, you have to have a boundary for that land spout. So again, that can be a temperature difference, that can be a moisture difference on this boundary, that can be an elevation difference. You can be higher up in one place and lower down in another, and that can form as the boundary. But you need a boundary, and you also need winds that are basically going in opposite directions along that boundary, because when you get that, you get some friction from two forces moving in opposite directions, and you start to get a little bit of spin with that friction. So once you get that spin, you're already well on your way to forming that land spout. Actually, what you need now is a little bit of upward motion, and that comes easy oftentimes when you have these convective environments moving upwards. You get upwards moving air that's rising, that's forming these clouds. And you need that upward air to form these clouds. But when it does, what it does is it takes that circulation and it brings it upwards. So it brings it closer and closer to the cloud base. And eventually, when the cloud base kind of mates with that circulation on the ground, you basically get something called a land spout. So that's basically the same process as that what you see with a water spout. The only difference here, again, is that it's forming over land. It's not forming over water. Now, if it does form over land, it can move over water and become a water spout, much like a land-based supercellular tornado can do the same and become a water spout, and vice versa. But again, these are a little less common just based on the fact that the conditions are not nearly as often seen that you see for water spouts that cause water spouts that you don't see those as often over land. But again, few differences here between a supercellular tornado and a land spout, one of those being the formation mechanism. You have a surface-based circulation for the land spout. You have a cloud-based circulation for the supercellular tornado. And again, you also have formation coming from the cloud for the supercellular tornado, and then you have it coming from the ground for the land spout. So a little bit of a difference there. One of them comes up from the ground, one of them comes down from the cloud. That's really hard to identify, but it is a key difference that comes with that formation process. Now, that's all I have for the latest edition of Weatherwise. As always, if you have any questions, feel free to post those on Facebook, on Twitter, on email, but otherwise, you guys have a great one.
Weatherwise is brought to you by 4 County Electric Power Association.